Hello everyone, this is Sister Lindsay Celestine, Assistant Professor, Department of Mathematics, St. Joseph College of Arts and Science for Women, Hosur. Okay, here we are going to see large sample test. In this we are going to estimate the unbiasedness for the population mean and variance. To estimate this, first we have to take the random sample from the large population. To differentiate the random sample values and the large population values, we are taking the random sample as small x1, x2, etc. in the size small n, and the large population as capital X1, x2, etc. xn in the size capital N with mean mu and variance sigma square. Okay, now what we have to do means we have to take the sample mean and variance, and we have to take the expectation or variance expectation for these two, and we have to prove this that the expectation of these are equal to this. That means that we have to prove expectation of this mean value is equal to this mean value, and the variance of this s squared equal to variance of this sigma squared. Okay, now we know the value of the sample mean and sample variance. Okay, sample mean is x bar is equal to 1 by n into summation xi, and the sample variance is s squared equal to 1 by n into summation xi minus x bar the whole square. Now since I already told that we have to prove that expectation of for this and expectation for this, then we have to equate these two to these two. Okay, then only we can tell that variance population mean and variance are unbiased one. Okay, next first we are taking the expectation for this value. Okay, so if I take expectation of x bar is equal to expectation of 1 by n into summation xi equal to, okay, we have the formula in the expectation of cx is equal to c into expectation of x, as well as expectation of summation x is equal to summation of expectation x. Okay, these two formula we have. Using these two formula we are using here. That means expectation of c is equal to summation x. So using that, here c is 1 by n, so we are taking this outside. In the second equation, summation x, so we are taking the e inside the summation using these two formulas. Okay, using these two formulas, then we get expectation of x bar is equal to 1 by n into summation expectation of xi. Okay, now we are considering the sample. We are telling that we have taken that a small xi is a sample observation from the population capital Xi. So since it is like this, it can take any of the values of xi, that means x1, x2, etc. xn, each with the probability 1 by n. Everything has the equal probability. So now we are writing expectation of xi equal to 1 by n into xi plus 1 by n into x2 plus etc. 1 by n into xn. In this 1 by n is in common, so we are writing 1 by n into x1 plus x2 plus etc. plus xn. So using that, we will take this equation is equal to mu. Okay, hence expectation of xi is equal to mu. So expectation of x bar, in the expectation of x bar we are substituting. Okay, expectation of x bar, what is the value? Okay, 1 by n into summation xi minus x bar the whole square. Okay, so 1 by n into summation xi. So in that, instead of expectation of xi, we are substituting this mu, so which is equal to 1 by n into 1 by n into expectation of xi value is mu, that we are substituting. So we get 1 by n into n types of mu, n into n times of mu. So this n and okay, this n and n will be get cancelled. We have only expectation of x bar is equal to mu. Since we have proved that expectation of x equal to mu, since we have proved this expectation of xi equal to mu, Okay, what we are telling, this sample mean is equal to this, is an unbiased estimate of this population mean that we have proved. Now we are going to the second slide. Now we have to find out the expectation of s squared. Expectation of s squared. Expectation of s squared equal to, we know the formula, expectation of s squared is equal to, already we have defined, that is 1 by n into summation xi minus x bar the whole squared, which is equal to expectation of 1 by n into summation x squared minus xi the xi squared equal to, okay, equal to, now using that formula we are taking 1 by n outside. Next, using this formula we are writing as using this formula we are writing expectation we are taking inside and summation we are taking outside. So expectation of xi squared minus expectation of x bar squared. Okay, now we have the variance formula, expectation of xi minus x bar, expectation of xi the whole square, so which is equal to xi, for we don't know anything, so xi we are writing as it is, and expectation of xi now only we proved, that is mu, so we are writing the whole square. Okay, now we are going to find the variance of x. So in this place xi minus mu, okay, for each expectation of xi means 1 by n into summation xi minus mu. So summation values 1 by 1 we are substituting, so 1 by n into all the summation values, which is equal to sigma square. Next, again also we have the another one variance formula, v of x is equal to expectation of x squared minus expectation of x the whole square. Here we know the value for v of x and e of x the whole square. Expectation of here we are going to see another one formula, expectation of x squared we don't know, so which is equal to v of x plus e of x the whole square. So in particular this x squared we can write is for xi also, this x squared we can write it for xi also. So xi squared equal to v of xi plus expectation of xi the whole squared, so which is equal to sigma squared plus mu squared, sigma squared plus mu squared, and we are taking this an equation number 6. From the equation number 5 we obtain expectation of x bar squared. Okay, here using this we have written xi squared, now we have to write x bar squared. Expectation of x bar squared is equal to v of x bar plus expectation of x bar the whole squared, but v of x bar equal to sigma squared by n, where sigma squared is the population variance. Okay, now what we are doing means we are substituting the variance of x and e of x bar in this equation e of x bar squared, v of x bar squared. So if I substitute like this, instead of this this one is will become expectation of sigma squared by n plus instead of expectation of x bar we have mu, so mu squared that we are writing. So from 6 and 7 we are substituting in 3. Expectation of xi squared equal to sigma squared by n, sigma squared plus mu squared, and another one is sigma squared by n into plus mu squared that we are writing. So here what we are doing, this value we are taking as it is, then what will come, plus mu squared and 1 by n into, here this value will not come. Okay, here this one will not come. Okay, this one value will not come. So if I not come, then it will become 1 by n into n of sigma squared plus mu squared minus sigma squared by n plus mu squared, because here already we have expectation value, that expectation value here only a constant values are there, so we are variables are there, so we are writing n times this one. So if I take this inside, so okay, this one will become minus and this also will become minus, so minus plus mu squared and minus mu squared will get cancelled. Remaining we have sigma squared minus sigma squared by n. So sigma squared, if we take out 1 minus 1 by n into sigma squared, which is equal to n into a minus 1 by n sigma squared. This is equation number 8. Since expectation of s squared is not equal to sigma squared, simple variance is not an arbitrary function. Okay, since this expectation of s squared is not equal to sigma squared, simple variance is not an unbiased estimated population variance. Therefore, from 8 we get n by n minus 1 into this one, we are taking that side. Okay, because we want to sigma squared as the answer. So n by n minus 1 into expectation of s squared equal to sigma squared, which implies expectation we are taking outside. So if we take outside expectation, we are getting for the whole term n s squared divided by n minus 1 the whole squared. N minus 1 is equal to sigma squared. So which implies expectation of n, instead of s squared we are writing expectation of xi minus x bar the whole square divided by n. So for this s squared formula, we know in the first slide itself. We know the first slide itself, that is what? S squared equal to 1 by n into summation x minus x bar xi the whole square. That one we are substituting here. Okay, so if I substitute here, we will get this answer. So variance of x we are writing here there. Okay, so now what we are doing, expectation of s squared equal to this one. So n minus n by n minus 1 expectation of s squared, expectation of s squared equal to sigma squared. Okay, wow. So here we are writing expectation of xi minus x bar the whole squared into of this s squared, we are writing this one, which is equal to sigma squared. Then expectation of s squared equal to sigma squared. Okay, that is expectation of s squared equal to sigma squared. So we have proved here, expectation of x bar equal to mu and expectation of x bar is equal to s sigma squared, where s squared equal to 1 by n minus 1 summation xi minus x bar the whole square. This is our unbiased estimate for the population mean and here population variance. Thank you.